Here is another nonlinear inequality. The first step is you want to have all the terms on one side. I usually move all the terms to the left-hand side. So that is 2x to the third plus ax squared and then minus ax minus 32, and then that is less than 0. So now you have all the terms on the left-hand side. I will just call this everything on the left-hand side a function. So I will just write let f of x equals to 2x to the third plus ax squared minus ax minus 32. And then we are taking care of less than 0, right? So temporary, we will just let the function equals to 0 to solve for x, and then we will call the x my key numbers. Now we have 2x to the third plus ax squared minus ax minus 32 equals to 0. And then we are trying to solve for 0 to get the key numbers. All right, so let's move the work over here. So we have a 2x to the third plus ax squared, and then I'm going to group the first two terms, and then I will group the last two terms. Ax minus 32 equals to 0. Now, can you tell me that did I make a mistake in the second parenthesis? The answer is yes, I make a mistake in the second parenthesis. Do you know why? Because once you group the last two terms, this becomes a plus. When you distribute the minus to the minus 32, you will get a plus 32. But this is a mistake, right? I have a minus 32. Distribute the negative, you have a plus. So this is definitely a mistake. That should be a plus. And then you factor out 2x squared in the first parenthesis. So 2x squared, and then you have a x plus 4, and then minus 8, x plus 4, and then equals to 0. And then you factor out x plus 4, right? You factor out x plus 4, x plus 4, and then you have 2x squared minus 8. Do we agree that we can factor out the 2 as well? So that one, we can just factor the 2 out. So we have 2x plus 4, and then we have x squared minus 2, sorry, not minus 2, minus 4 equals to 0. So, and then we have 2x plus 4, and then x plus 2, x minus 2, equals to 0. So the key numbers are x equals to negative 4, x equals to negative 2, and x equals to 2. So let me write the interval first. So we have our interval, and then we have a negative 4, we have a negative 2, we have a positive 2. So that divide the number line into 4 intervals. The first one is negative infinity to negative 4, and then from negative 4 to positive 2, from positive 2 to from negative 4 to negative 2, negative 2, from negative 2 to positive 2, and then from positive 2 to positive infinity. So we have 4 test intervals. Let's write this down. Negative infinity to negative 4, and then from negative 4 to negative 2, from negative 2 to positive 2, and then from positive 2 to positive infinity. And then the key numbers, let's use a different color to write that down. So for the key numbers, so the key numbers are, where is a good spot to put this? So the key numbers, I will just put it right here. So the key numbers are, so from this line, the key numbers are x equals to negative 4, negative 2, and a positive 2. Negative 4, negative 2, and positive 2. And then you use the 3 key numbers to set up to find the test intervals. All right, and then moving on to the table, now we have 4 test interval, and then what do we do with that? We pick a value within each test interval, plug it into the function to see if that is less than 0. So within the first interval, what do you want to pick? Let's pick something easy. I'm going to pick x equals to negative 5. You can pick negative 6, negative 7, negative 10, negative a million, but if the number you selected is too big, you will have some trouble when you evaluate a function. I haven't seen students pick a huge number yet. I would just stick with easy numbers. Negative 4 to negative 2, I will pick x equals to negative 3. This one definitely pick x equals to 0. This one definitely pick x equals to 3. And then you evaluate f of 3, f of 0, and f of negative 3. and then you have to see which one is less than 0. So that one you have 2 times negative 5 to the third power, 8 times negative 5 to the second power, minus 8 times negative 5 minus 32. This is a 2 times negative 3 to the third. Let's just write this first. 0 to the third, and then 2, 3 to the third power, plus, 8, 8, 8, right? And then you have negative 3, 0, and then positive 3, second power, minus 8, minus 8, minus 8. This is times negative 3 times 0 times 3. Forgot the minus, minus 32, minus 32, minus 32. So that should take you some time to use your calculator to evaluate what that equals to. If you don't want to waste that time, let me just tell you what that equals to, because I did the work already. The first one is negative 42. The second one is 10. The next one is negative 32. The last one is positive 70. Now, what are we looking for? We are looking for a less than 0 right here. Why is this less than 0? Did I just make this up? No, because the problem starts with a less than, and then we have less than 0 right over there. And then which one of these is less than 0? The answer is this is less than 0, and then this is less than 0. So those two intervals are less than 0. So we pick a value, test the interval. It turns out that that interval is less than 0. And then we are picking this, and then we are picking this. So we have two solution set, which are those two intervals. So for the solution set, I'm going to summarize everything. So the solution that we are looking for is from negative infinity to negative 4. Usually the textbook, if you read the book, they will just use a U. This U stands for union. Union means a comma. From negative 2 to 2. By the way, what is union mean? In math, union, you can treat that as a comma. You can treat that as an or. Why do I use an or, not an and? Because every time you select an x value that fits the inequality, the x value is either in this interval or this interval. Again, why do we use or? Union means or. Why do we use or? Because every time you select an x value that fits the inequality, the x value must be either in this interval or in this interval. That's why it is an or. And then you draw the number line. So we draw a number line like that. And then we have a negative 4 past negative 2 and then to positive 2. So we want less than negative 4. And then we want between negative 2 and 2. That's all we need. So this is x less than negative 4. This is x between negative 2 and 2. Now, there is a what if. So back to the second line we did. What if that is less than or equal to 0? So let's use red. I'm going to use red for that. So what if? I'm going to copy this one more time. So what if you have 2x to the third plus ax squared minus ax minus 32 less than or equal to 0. What happens when there is an equal? So when there is an equal, everything else is the same, but when you write the solution, instead of writing everything all over again, I will just copy that, paste that over here and tell you what to fix. So since we have a less than or equal to 0, then you have to include the negative 4. So this is not a parenthesis, that becomes a square bracket, that becomes a square bracket, that becomes a square bracket. So this is a solid circle, this is a solid circle, this is a solid circle. What does that mean? Solid circle and square bracket means it is okay to include negative 4, negative 2, and positive 2 when there is an equal. Alright, so that is the end of this video. With all that said, I hope you guys are learning effectively from my video. Keep subscribing for more lessons. As always, I will meet you all in the next video. Signing out.